Alright, okay, let's look at this question. This question is asking you to show that the line is parallel to the plane. But this line does not lies on the plane. Alright, it show that it's parallel to the plane but does not lies on the plane. Okay, this will become with another example in your lecture notes. Alright, in your lecture notes, they will have two examples. One is to show that the line is parallel to the plane. Both also show that the line is parallel to the plane. But the other example will be showing that it lies on the plane, and for this we show that it does not lies on the plane. Alright, so let's see the difference here. Very simple. Okay, at first you want to show that the line is lies on the plane. Then you have to understand the concept of parallel, the meaning of parallel of a line with a plane. So there are three lines here, right? Three lines. Okay, two line. All right, two line. So definitely this line. Let's say this is a line, right? If I draw extended this line is not parallel to the plane. It's not parallel to the plane because it's intersect the plane. Memintas plane itu intersect the plane at a point, right? They intersect the plane at a point, and it's actually, we said that this line is passing through the plane. All right, but this definitely is not parallel. All right, not parallel. So if not parallel, they were making an angle, right, which is not 90 degree. So, and if this is parallel, if this line is parallel, okay, let's see. All right, let's see what is meant by parallel, right? Parallel means that the line is parallel to the plane. Very hard for me to describe, so I just draw for you. Okay, means that if they are parallel, if you're able to bring this line go to the plane, right, it will be exactly on the plane. It can be on the plane, but doesn't mean all the line that parallel to the plane. Not all. My statement here is not all line that parallel to the plane will be on the plane. Okay, that's why they're asking you to show that does not lies on the plane, right? So if the line, but the most important thing at first, you must show that the line is parallel to the plane, right? So you see the question? Show that the line is parallel to the plane. Okay, let's look at this statement first. So how to show that the line is parallel to the plane? Very easy. As you know that the plane having a normal, right? Having a normal, and the line having a direction, right? The normal, if this line is parallel to the plane, the direction of the line will be perpendicular to the normal. Very easy, right? Because this is normal, this is the direction of line. The direction for this normal and the direction for this line will be definitely 90 degree if they are parallel, right? If this line is parallel to the plane. So how, if you're able, conclusion here, if you're able to show that n dot v is 0 lah, the meaning here, because based on scalar product, if you remember that, if a dot b is 0, vector A is perpendicular to vector B, right? This is the properties of the scalar product. So now I have to identify where is the direction of the line. From this is the equation of the line. The direction of the line here will be will be V. I label it to be V. This is my V, right? My V. I write in column vector form 1, -1, 4. And the normal of the plane, which is already in vector form, this is R dot N equals to A dot N, right? You produce a D here. So R dot N, this will be your normal. Your normal will be 1, 5, 1, right? 1, 5, 1, the vector I plus 5j plus k, 1, 5, 1. Okay, let's see. Okay, let's see whether the line is parallel to the plane or not. The first condition here. So n dot v or v dot n. Okay, v dot n or n dot v is the same thing. Okay, so 1, 5, 1 dot with 1, -1, 4. Okay, let's calculate. All right, we need to calculate. 1 times 1, 1. Positive, negative, -5. Plus with 1 times 4, 4. 1 minus 5, -4. -4 plus 4? Yes, you're getting 0. 0 is already enough to show that this line, is parallel to the plane. Again, I remind you, because why? The direction of the line and the normal of the plane is perpendicular to each other. When they are perpendicular to each other, means that the line is parallel to the plane, right? The first, okay, I have done with show that the line is parallel to the plane, but I have to show also that the line does not lies on the plane. Does not lies on the plane, very simple, okay? Okay, I'm going to explain to you. All right. Just now we have already shown that the line is parallel to the plane, but does not lies on the plane. Does not lies on the plane. Because why? Because a line that parallel to the plane, will be either not on the plane or is everything on the plane, right? It's got two possibility only, either on the plane or not on the plane. But if the line is not parallel to the plane, definitely it will not on the plane, because they will intersect the plane at one point, right? So, okay, let's think about this, right? On the plane or not on the plane? So, very simple. If one of the point, okay, try to think, okay, try to think. I can't tell you straight away, you can understand, no. You need to cooperate with me so that we're thinking during you read the video, okay? When you study the video, you have to have some willing to think. So you see that if this is a point, let's say this is the point on the line, but this point is not on the plane, then what's the meaning here? This line is parallel to the plane, right? Parallel to the plane, but this point is not on the plane. It's already enough to show that the whole line is not on the plane, right? Because this point is not on the plane, right? If you want to show that the line is on the plane, means that every point on the line must be on the plane, right? Must be on the plane. So, if you say that this point is not on the line, is not on the plane, you have shown that this point is not satisfied the equation of the plane, definitely every point on the line now is not on the plane also. But if you can show that this point, one of the point is enough. One of the point is on the line, is on the plane. One is already enough, is on the plane. Definitely every point on the line will be on the plane. Because why? The line is parallel, right? The concept is the line is parallel, right? If one is on the plane, everyone is on the plane. If one is not on the plane, every point is not on the plane, right? So very easy. So I just need a point on a line. I just need a point on the line to do the final decision, all right? Okay, now I know that from my knowledge of the formula of R equals to A plus TV, right? Definitely, this is a point on the line, right? Based on the formula, R equals to A plus TV. So this is the direction of the line, and this is the point on the line, right? So then I can using this point to verify or do the final decision. All right. Okay. Now look at here. A plus TV. This is the point. This is the point. So it means that I will change this to become a coordinate, as this is really is a position vector, right? 2, -2, 3. Right. Okay. The equation of the plane. The final decision will be, I change it become Cartesian form. All right. Cartesian form is supposed to be equals to 5. Okay. I repeat again. It's supposed to be equals to 5. If this point satisfy this equation of plane. I repeat again. If this point satisfied the equation of the plane, it will give the value of 5. So it means that the x, y, z will give you the value of 5. So let's see. All right. Let's see. So plus z. X. What is x? 2. What is y? -2. What is z? 3. So you're getting 5 minus with 10, right? 2 plus 3, 5. You get -5, which is not the same as 5. It's not 5. You already proved that this point is not on the plane. Sir, how you know this point is not on the plane? Very simple. You substitute the x, y, z. The equation of the plane is x plus 5y plus z is 5, right? It must be 5. So, it means that any point on the plane that you substitute, it will be getting 5. But now you have proved that this line having this point is substitute inside here, you're getting -5. -5 does not satisfy because it's not 5. So you already show that the line does not lies on the plane, right? Very simple. If one of the point is not on the plane, the whole line is not on the plane. That's 4. So you just do some explanation, all right? Then make sure that you convince people that you show that the line does not lies on the plane. Alright, okay, let's talk about method 2. Alright, I have another method to showing this in a very fast way, right? But I have to introduce you the concept just now, okay? It's very important for a mathematician to know how to explain the situation, right? So, let's say you have, okay, another way would be you know that the parametric form of the line, right? The line, you're solving simultaneous equation, show that it does not satisfy, alright? So x equals to 2 plus t and y equals to -2 minus with t and z to be 3 plus 4t, right? The parametric form. So, and this line you have x plus 5y plus z equals to 5. And if you put all the value of x, y and z here into the equation, and you show that it get a value that different from 5, this already show that the line does not satisfy the plane. The line does not satisfy the plane here means that it means that we can show that the line is not on the plane, right? The line is not on the plane. This is an easier way of doing, all right? It's easy way of doing, but it's lack of understanding, right? Lack of understanding. Alright, means that you not understand deep enough. Alright, so x, so you have 2 plus t plus with 5 times with -2 minus with t plus with z 3 plus 4t. So then you calculate, just calculate, very simple, -10 -5t plus 3 plus 4t. So if you see that t minus 5t, -4 plus 4, 0. 2 minus 10, -8 plus 3, you get -5. -5 is not the same as 5, right? It's not the same as 5. The meaning here is very simple. This is represent every point on the line, right? This is t. T means what? Okay, I have to tell you again. Every point on the line have different value of t. Maybe t is 0, t is 1, t is -1, right? Every value of t will give you one coordinates on the line, right? So now, based on this, I assume that t can be any value, I have substitute this into the equation. Means that if I use any value, substitute to this equation, I get any value that I substitute, I cannot get 5, I get -5. Means that any value of t, all value of t, for this line does not satisfy the equation of the plane. This has already shown that every single point on the line with different value of t, this is general, with different value of t, you substitute, you're getting -5, means that none, alright? None of the point is on the plane, right? None of the point is on the plane. This is another way of showing that the line is not parallel, the line is parallel to the plane. This is quite tricky here, right? This line is not on the plane. This line is not on the plane at all. But I have proof it's parallel. Why? Through this short working, I can know that it's not parallel. Because why? You see, any value of t for every point on the, you know, I use the word every, you know, every point on the line with different value of t does not satisfy the equation of the plane, give you -5. This have already shown that the line is parallel to the plane because every point. If, let's say, not all the point, but have a point, not every point on the plane, is satisfied, but there is a point satisfied. At least this line is not parallel, is intersect, right? Because so many points on the plane, not all the point is not on the plane, but one of the point is on the plane, right? But this I show that every point, generally, every point is not on the plane. This is another meaning to explain that the line is parallel to the plane, but not intersecting the plane, or not lies on the plane. Okay, this is for you, for those who want to have deep thinking about the concept of parallel and parallel between a line and a plane. Alright, okay, that's all for this video.